We are looking at the chart style way of solving stoichiometry problems on page 8 of your homework packet. And I think the first thing I'm going to do is I'm going to balance this equation. Looks like it's a single displacement reaction. I have a sodium and I have a sodium, I have a copper, I have two chlorines and one chlorine. So I'm going to put a 2 out in front here. That assumes this is a 1. So I got two chlorines. That makes two sodiums. So I'm going to put a 2 here. And I have one copper here. So that's going to be one copper here. So it looks like it's combining in a ratio 2 to 1 to 1 to 2. Is that a gram ratio? No. Otherwise, I could just say 138. What, 1 is half of 2, cut that in half, say 69, 138, and I would be done. But we have to do more work in order to figure out the masses in this reaction. So this would be if I took sodium metal, put it in copper chloride solution, the sodium would replace the copper, it'd form copper and leave iron chloride, kind of like our iron copper chloride lab that we looked at earlier, the single displacement. Okay, to do the chart style thing, I think the next thing I'm going to do is fill in all my molar masses. So I'm going to find the molar mass for sodium, which is, I think I'm just going to put these in here. It's 23. Now notice there is a 2 in front, or maybe I'll say 23.0, and we'll just finish these up here. And then copper chloride is 134.6. I'm going to keep going here. How did I figure that out? I got sodium from my periodic table. I got copper and chlorine from the periodic table. And then I show the work right up here. One copper is 63.6. 2 times 35.5 for chlorine is 71. I add those up, I get 134.6. Okay, copper I get from the periodic table, and that is 63.6. And then I get this sodium chloride. I did this one up above. It's 23 for sodium, 35.5 for chloride. I add those two, and I get 58.5. I would say doing these the nearest tenth will be fine for these molar masses and these chart style problems. Okay, so we have this right here. Notice for the molar mass, even though there's two sodiums, I just take the molar mass of sodium. I don't double it because of that 2. Or I take the molar mass for sodium chloride. I don't double it with the 2. Just include the molar mass that's given. We'll account for mole ratios in that 2 in the next step. So this is one where I got to remember from my mole train. Going from grams to moles, I have to divide by the molar mass. So if I take 138 divided by 23, I get the nice number of 6.0. Okay, and if I take, now how do we go from sodium to copper chloride? Well, the ratio is 2 to 1. So 2 is twice as big as 1. So 6 should be twice as big as 3. So I'm going to put 3 there. Notice 2 to 1 to 1 to 2 is the same ratio as 6 to 3 to 3, and then compare that to 6.0 right here. So twice, 6 is twice as big as 3, 2 is twice as big as 1. 3 is the same as 3, 1 is the same as 1, and so on. I could look at this and say 6 times 1 over 2, where I'm going to goes on top, where I come from goes on the bottom, and that equals 3. Or looking at it this way, 3 times 2 over 1 gives me 6. Notice when we did mole train problems, we only compared 2 things. Here we're actually doing a comparison on all 4 things, and in a relatively short amount of time, we can solve it. So this can be a really effective method if you're trying to find not just one particular thing, but a lot of things, the quantities of a lot of things in an equation. What did we do? We took 138 divided by 23 equals 6. So it should go multiplying in the opposite direction. 6 times 23 is 138. So then 3 times 134.6, I multiply that through, and I get I get 404, right? And then I carry this 3 times 63.6, and I get 191. And I carry that through, and I take 6 times 58.5. I'm going from bottom to top, and I get 351. Okay, so now I've kind of solved these things in one quick thing. 3 times 134.6 is 404, et cetera, going up. All right, so now I've completed the box. Sometimes you're asked about moles. A lot of times you're asked about the masses of these things, and then you can solve that. Now, what happens, a way to double check to make sure you're right, remember conservation of mass. My two reactants should add up, 138 and 404, to equal the mass of the products, 191 and 351. So I could look at this and say, and maybe I'll get a different color here. Okay, let's try this blue. Okay, is that going to switch for me? No. Let's try it again. Let's try this. Switch to blue, and hopefully that's going to work. Okay, so I'm just going to draw a couple of these things in, and I'm going to write up here 138. Oh, didn't switch, but I think it's going to be fine. I'm going to say that is plus 404 should be equal to 191 plus, I'm going to squeeze this in a little tighter here, and I'm going to say 351. Oops, I didn't want to go that far over there, plus 351. So I'm saying the two reactants of the masses should equal the masses of the products, not the molar masses, not the moles, but the actual masses. And if I do a little bit further calculation, I think 138 plus 404 ends up being 542. And you can double check this. And the other one is 191 plus 351 ends up being 542. So these two things should match up. Occasionally, it might be off by a small amount. That would be rounding, but it should be actually the same or reasonably close with the rounding. So that verifies that, unless it's coincidence, it's a lot more likely that I got this correct because we have that conservation of mass. Okay, let's do the next problem below. It's with the same equation. This time I start with a 1.5. So a couple ways to look at this. I could say, oh, this is 1.5. Where I come from goes on the bottom, where I go goes on top. So 1.5 times 2 over 1 gives me 3. Okay, the other way to look at it is, hey, 2 is twice as big as 1. 3 is twice as big as 1.5. So I'm going to write this in here as 3.0. And notice 2112, it's going to be what? The middle two numbers are going to be the same, so that's going to be 1.5 because it matches up with that ratio. So I'm going to call this 1.5 right here, and then I'll call this 3.0 right here. So this number is twice as big as this. These two are the same, and then this one gets to be twice as big. Okay, our molar mass is the same, yes. So if we're solving the same thing, the molar masses won't change. 23.0, I'll keep going, 134.6, and I'll keep going, and I'll say 63.6, and then the last one I'll say 58.5. So I'm just copying down those molar masses, which we figured out before. And remember, going bottom to top, we multiply. So we end up with 3 times 23 is 69. And I think I'm just going to round it to the nearest gram in these. 1.5 times 134 is 202. Keep going. 1.5 times 63.6 is 95. And the last one, 3 times 58.5 is 176. Now you could try to set this up and prove this. You could add this and say, oh, I think this is 271 on this side. If you add this, this is 271. So that would verify that you have a conservation of mass. Just a couple things. Notice with this one, I had half as many moles. The molar mass is going to stay the same, but I'm going to have half the mass. Okay, so if I cut the moles in half, the molar mass will stay the same, but that means the mass is going to be cut in half. And that's what happened there. So you can kind of see some different patterns and how it's not just a train, it's almost like a web with all these different things. Okay, so how does this chart style compare to the mole train? Let's just take a look at something as we wrap this up. So I have a mole train, I turn it over on its side. And what I think I'm going to do is get rid of these numbers here. Okay, and then I'm going to bring this up. Here's our mole train on its side, and we kind of see our same numbers right here. So I'm going to just look at this last equation right here, and I'm going to look at this part of the mole train. And notice, let's say I was going from, let's say I'm going to compare any two things. Let's say I wanted to compare the sodium here to the copper here. So let's just look at those two things. And comparing this sodium column to this copper column. What am I going to do? I'm starting with my mass, which is 69. I'm going to divide by the molar mass. I'm dividing by 23. That takes me to moles. So I'm starting here, and then I'm working down like this to get to moles. Okay, how do I go from moles of this to moles of this? I go through the mole ratio. I'm coming from 2, so that goes on the bottom. I'm going to 1, so that goes on the top. So to go from 3 to 1.5, I multiply by 1/2 or 1/2. So that takes me here. Okay, so now I'm here. And then, so I went first one, divide by molar mass. Next one, I'm going this way. And then the last step, I'm going to work back up by multiplying 1.5 times 63.6 gives me 95. So I'm going to take my moles times the molar mass, and this time it's the molar mass of the copper to get to my mass here. So notice this kind of U right here is the same as this U with the mole train turned on its side. So it really is the same type of mass to mass problem that we have been working on. Thanks for watching.